Welcome back. This is the Tutor Wizard. I'm Adrian. Please subscribe right here. Hit the notification bell for this series and a bunch of others on our channel. We're doing Linear Algebra 1. This is Chapter 1, which is Systems of Linear Equations. We're in Section 1.7, which is Gaussian elimination and row echelon form. This lecture specifically, we're going to discuss reduced row echelon form, or rref, and the process of Gaussian elimination, or some of the books are technical and add Gaussian-Jordan elimination for this one specifically. So the way I remember is if you're going to add Jordan to Gaussian, I add an R to rref. Gaussian elimination goes to rref. Gaussian-Jordan elimination goes all the way to rref. But the process is the same. You augment the matrix, use the row operations, get it to the nice form, decide what kind of solution we have. Let's give the definition explicitly. Okay, this time we can get straight into it. We know what we have. We have a linear n by n system. We have an augmented matrix. We know hopefully what row echelon form is. If you don't remember, this is it quickly, but look at the previous video and those are all the gory details of how to get row echelon form. To get reduced row echelon form, which is really nice, and especially for a unique solution, you can just read off what the solution is. This says x is 7 over 2 and y is 1/2 when you turn that back into a system. So it's just going to read off in the reduced row echelon form. It just gives you the answer. You don't even have to do any back work, but you have to train yourself to be able to get it all the way. Put it in a computer, it will do it for you, and then it'll just read off the solutions. So to have reduced row echelon form, I need one, it's in row echelon form. And that's kind of lazy because that's 3 axioms. So to be in row echelon form, you have to have 0 rows below non-zero rows. You have to have zeros below leading entries. And you have to have the staircase of leading entries. Look at the previous video for what that means. But if you have top left to bottom right, you need your ones to go down this way. And you don't want them directly below each other or further to the right when they're lower. Then once I have rref, now what we're going to change is, and this is why I've got 2 rrefs and 1 rref. Rref is not necessarily unique, dependent on whether you make it a leading 1 or not. But our second condition now is to go to rref, you must make all leading entries leading 1s. That's actually not anything really new. Just I like to train rref to be leading 1s. My mantra is get a leading 1, kill below, get a leading 1, kill below, get a leading 1, kill below until you're in rref, and then we are off to the races, so you'll have leading 1s. And our last condition is going to be, for rref, you need zeros below the leading entries. Now what I need is zeros above the leading entries as well. So zeros in that column entirely. For 2 by 2, it's either going to be 0 or above or below. When we have 3 by 3 or 10 by 10, you can have all kinds of different scenarios, and you need, whenever you have a leading entry, it has to be zeros below that and above it in that column. So specifically, this is that same system we're doing, x plus y equals 4 and x minus y equals 3. I augment the matrix. It's not in rref, so I keep going before I make a decision. One move, and I subtract those rows, I get this. That is in rref. Rref is not unique because I like to, my next move is get a leading 1 and keep going if you have a larger system. So I would make that a leading 1. I do that move. This is also an rref. This is a leading 1 and a leading entry. This is a leading 1 and a leading 1. So those are both row echelon forms. It is unique up to the constant. But reduced row echelon form, now there's only one. This is extremely useful for proofs and theoretical considerations because we don't have to talk about, well, what if I got a different rref? There is only one. And so if we insist that all the leading entries are 1s and we get 0 below, there can be a unique reduced row echelon form for every augmented matrix of a system, which means that regardless of what the starting things looks like, and whichever moves you use, and you shear a sheep a different way than I do, and get over here, there could be bleeding, there could be someone puking in the corner, I don't really care. I just want to see a hairless sheep at the end. You don't have to follow what I want. If you do the operations correctly in any order you want, you have to get the same reduced row echelon form that I get. And you have to get the same rref up to the leading coefficients being leading 1s. Doesn't matter which way you do it. If you do it correctly, you'll get the same thing as me. So if you're comparing, at least one of you is wrong because there's a unique one. Let's try this out. Okay, example 1. Decide if each augmented matrix is in rref, reduced row echelon form, or neither. What we want to do with each one is eventually we're going to be awfully close and they're going to try and trick you with this. So you have to run through the mantras. First of all, do I have any 0 rows? No, so I can ignore that axiom entirely. Now I only have 2 left. If I have leading entries, do I have zeros below? Leading entry, yes, zeros below. Leading entry, yes, zeros below. Leading entry, I can't get any, so axiom 2 is now done. I don't have to worry about axiom 2. Axiom 3 is the only one. And now, if you have what we're trying to say in that horrible description is, if you have the nice staircase, remember I had 3 unknowns probably. We didn't show you what the system looked like. We just threw one at you. But if it came from this, I should point that out. When I say augmented matrix, that means it's not coming from some willy-nilly rectangular array of numbers, which we haven't even defined, which we're going to do in the next chapter. Augmented matrix specifically means that it came from a linear system. So anytime I say augmented, I'm already a priori assuming that it came from some system that I've augmented. So I had 3 variables was my point. I have 3 leading ones in a staircase. So this is REF, and there's going to be a unique solution to this system of 3 equations and 3 unknowns. So when I compare, they're further to the right in the lower rows. The next one, so this is REF. Is it in reduced row echelon form? No. This guy is the problem now. There should be zeros above, it says, and this one's okay, and that spot's okay, but that has to be a 0. If I want it to be in reduced row echelon form, what would I have to do to it? I have to change this equation. So the operation I would use is row 2 gets replaced with row 2 minus 3 times row 3. I won't get into it, but what that's going to turn it into is that. That is now reduced row echelon form of the same thing, and it's equivalent. And now you can just read off. Do you see what it says? X3 is 2, X2 is 1, and X1 is 5. It reads off the solution when you're in RREF. There's no backtracking even. Good. The next one, I'm in RREF. Why? Because I'm in REF. I check. I have 0 row. It's at the bottom. I have leading entries. There's zeros below. Good. In any 2 non-zeros, when I compare, the one in the lower is further to the right than the leading entry in the upper row. Good, that's REF. Now what do I need to make sure? All the leading entries are leading ones, which they are, and I have zeros below and above leading ones. Yes, this is reduced row echelon form. This one again is close, but this guy's ruining it. It's in REF. Why? I have a 0 row. Check. It's at the bottom. Do I have non-leading entries? Yes. Zeros below. And then, that was a mistake. Did you see it? Don't wait till you analyze. He's not a problem. This is reduced row echelon form. Why? Because when I look carefully, this is not a leading entry, so I don't care if there's a 2 above it. This is the leading entry. He has zeros above and below. Leading entries, zeros below, can't have them above. This is reduced row echelon form. But now in reduced row echelon form, you still have to do a little bit more work to find the general solution. If it says decide, then I can say we're in RAF, there's infinitely many solutions. I can tell right away. Why? Because I have a row of zeros and I'm in reduced row echelon form. But if I actually want the solution, it says solve it, I have to see what that says. That says x2 plus x3 equals 2. Because I have 2 unknowns in one equation. One of them is free. We're going to let x3 equal t. And we solve from there. That's what we're going to do in the next example. But this is the difference between just deciding whether I have infinitely many and listing the general solution and giving us all of them. In the next one, this is not REF or RREF. There's multiple things wrong, but in particular, the 0 row is not at the bottom, and these leading ones are in the wrong order. So you would have to interchange those 2 rows and move the middle row to the bottom. Then it will be in what? I can't tell unless we do it. 1, -1, 2, 7 should go to the top. Then 0, 1, 3, 2, 0, 0, 0, 0. This is now, I can see, in REF, but not reduced row echelon form, because that needs to be 0, like that one. This is how we recognize it. Now let's go through and do all the way again with a 3x3 from the system, augment the matrix, row reduce it, and then decide whether we have solutions or not. All right, let's do this all the way through. I have a linear 3x3 system. Immediately I augment the matrix. 1, 1, 3 equals 5. And then I have 1, 0, 2 equals 2. And 0, 1, 1 equals 2. My first move is to get a leading 1 in the top left corner. I have that, and I want to get zeros below that, so it has the mantra of row echelon form. I have a leading entry, it has to have zeros below. So if I make this a leading 1 or a leading entry, I know my next moves have to be in REF, that those are zeros. So that tells me what my next move should be. I have a leading 1. If you don't, that's your first move. Get a leading 1. If you do have a leading 1, move to step 2, which is eliminate below that leading 1. We're going to do that right now. How am I going to do that? Replace row 2 with row 2 minus row 1. So I denote that for you so that you can see, and you do it for me when it's your turn. Row 2 is getting replaced with row 2 minus row 1. That's what I'm trying to do. These operations are weird at first, so that tells me if you make a mistake, that's what you were trying to do. Now I try to do it. There is no try, do or do not. I'm going to do it now. I'm going to get 1, 1, 3, 5, and notice how I'm trying to work as fast as I can. I'm not manipulating row 1 or row 3, so I'm just copying them down as fast as I can. Now thinky brain on. 1 minus 1 is 0. That's why we did it, to get him to be a 0. 0 minus 1 is minus 1. And 2 minus 3 is minus 1. And 2 minus 5 is minus 3. I really like the fact that that's happening. This is going to give us, are we in REF? Every time you make a move, you want to ask yourself, am I in REF? And you're praying, please. And I'm going to make sure that it's at least 3 or 4 steps on an exam. So not yet. Are we? This one's good. And actually, I need to point this out too. Once we have a leading 1 here, and then 0 below it, for all intents and purposes, here's how I know, and then you need to train where my next move is. I want to move to the next column if possible, because I'm completely done with column 1 and row 1 now. Why? Because if you look at that, I've completely eliminated the variable x1 from this system. And now if I temporarily, it's not the way you're going to view this, but if I temporarily view that as a system, watch what happens if I ignore that temporarily. That says is negative x2 minus x3 equals negative 3, and x2 plus x3 equals 2. That's a 2 by 2 linear system now. I've eliminated x1 from the entire system. So if I ignore that temporarily, I now have a 2 by 2 system, which we know how to solve. So what would I do with this 2 by 2 system? Get a leading 1 in the top left corner and eliminate below, so I know what my next move should be, because I now have a 2 by 2 system that I'm solving. And once I see that, I know what my next move is. To be lazy, I'm probably just going to interchange those 2 rows, or multiply by negative 1. I have more than one choice. Let's do that, because we haven't done it yet. Let's replace row 2 with row 2 times negative row 2. And that gives me 1, 1, 3, 5. 0, 1, 1, 3, 0, 1, 1, 2. And now I can see the jig is up, but I'll go there first. There's no solutions, because when I subtract, we're going to get a contradiction. Don't make a decision until you're in REF. Am I in REF? No. This is a leading 1 now, good, but I need a 0 below that. So this has to go. That tells me what my next row operation should be. I need that to be 0. How do I do that? Subtract it from this. That tells me row 3 is going to get replaced with row 3 minus row 1. Then I do that, and I get 1, 1, 3, 5, 0, 1, 1, 3. I didn't change that. And now we get 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 1 is 0, and 2 minus 3 is negative 1. Is this REF? Yes. And for all intents and purposes, until we do chapter 2 and we do the inverse matrices, I don't need reduced row echelon form anymore secretly, but if we want to go to reduced row echelon form, what's the last thing I have to do? This is definitely an REF. And I can tell there's no solution. REF is the best case scenario, because now in REF in the last row, I can tell that 0 times x1 plus 0 times x2 plus 0 times x3 is equal to negative 1, but that's 0, and 0 does not equal negative 1. So this is 0 is supposed to equal negative 1 if we have solutions. Therefore, there's no solutions to this system. The goal is, again, take a linear system, augment the matrix, use the 3 operations called Gaussian elimination to turn it into a row echelon form. And then in the last row, for all intents and purposes of REF, I can tell whether there's no solution, one solution, or infinitely many solutions. Please subscribe and hit the notification bell. I'll see you next time.